Yep. So the function f is defined by f of x is equal to that. Find f minus 1 of 7. Okay, so we need to work out the inverse function in general. So we let, well, we could do it where we let x equal, so I'm going to rewrite the f of x function, but replace x with y. So 3y minus 7 over x minus 2. Oh, sorry. My gosh, I literally just said it and then I didn't do it. Over y minus 2. So I'm going to rearrange this to make y the subject. So if I multiply both sides by y minus 2, I get x times y minus 2 equals 3y minus 7. Then I multiply out the bracket, so I get xy minus 2x equals 3y minus 7. Then I'm going to subtract 3y from both sides and add 2x from both sides. So I have xy minus 3y is equal to 2x minus 7. I've gotten everything with y's on one side and everything without y's on the other side. I can now factorize the y, giving me x minus 3 equals 2x minus 7. Dividing by x minus 3, I get y equals 2x minus 7 over x minus 3. So that's my inverse function. And then f minus 1 of 7 is equal to 2 lots of 7 minus 7 over 7 minus 3. So that is 7 over 4. Yep. Lovely. Okay, let's go to part B. So show that f of x is equal to ax plus b over x minus 3, where a and b are integers to be found. Okay, so first of all, f of x, f bracket f of x, so we're putting the function into itself. So it's going to be 3, so I'm going to replace x with f of x, so it's 3 lots of f of x minus 7 over f of x minus 2. And of course, we know that f of x is equal to 3x minus 7 all over x minus 2. So that's 3 lots of 3x minus 7 over x minus 2 minus 7 all divided by 3x minus 7 over x minus 2 minus 2. And now we just need to simplify that a little bit. Okay, so it seems like it's quite a lot going on, but we can make this a lot easier for ourselves. So first of all, we're just going to expand the top a little bit. So that 3 that's being multiplied by the fraction, really we're just multiplying by the numerator. So that becomes 3 lots of 3x minus 7 over x minus 2 minus 7 all divided by the same 3x minus 7 over x minus 2 minus 2. Now, if you look at the fractions in the fractions, they both obviously have the denominator of x minus 2.
Yeah.
So that's this part and this part. Let me just go back. So then that means that if I multiply the numerator of the main fraction and the denominator of the main fraction by x minus 2, that gives 3 lots of 3x minus 7, if you multiply that part by x minus 2, minus 7 times x minus 2. So that's that bit multiplied by x minus 2. All divided by, and then if I do the bottom part also multiplied by x minus 2, that gives 3x minus 7 minus 2 lots of x minus 2.
Okay, yeah.
I'm just going to pause just to make sure that you have taken everything in.
That's where I got confused, because there were so many fractions, and I tried like with the -7 on the numerator and the -2 on the denominator. I tried to like find a common denominator between the two, so just timesing them across and stuff. But I just got in a big mess, and I didn't really like what they were trying to make us show.
You could, yeah, I mean, that can be done too. I mean, I just did it this way to prevent myself from having to add fractions within fractions. So I multiplied the numerator of everything by x minus 2 and multiplied the denominator also by x minus 2 because I'm allowed to do that. It doesn't change the value of the fraction.
Yeah, it makes it easier when there's only one fraction.
And then now we can expand the top and simplify. That's it. So 3 times 3x is 9x. 3 times -7 is -21. Minus 7x plus 14 because it's -7 times -2. All divided by 3x minus 7 minus 2x plus 4 because it's -2 times -2. Simplifying to 9x minus 7x is 2x. Minus 21 plus 14 is -7. All divided by 3x minus 2x is just x. -7 plus 4 is -3. So, I mean, we can be quite confident that it's the right answer because at the top, we've got something times x plus something else. In this case, a is equal to 2 and b equals -7. And at the bottom, the bottom says, so that it simplifies to x minus 3, and we have x minus 3. So that is great.
Yeah, okay.
Lovely.
Yeah, that makes sense now.
Awesome. Was there more to the question, or was that it?
No, that was it.
Oh, lovely. Brilliant.